This is how to wire an extension cord plug, both ends of mains extension lead, done properly. A 3-pin plug on one end, a trailing socket on the other, and 3 conductors running between them, live, neutral, and earth. Let me show you every terminal, then draw one live. Here is the whole idea in one picture. An extension lead is just one length of 3-core cable with a plug on one end and a socket on the other. Both ends use the exact same 3 conductors in the exact same order. Brown is live, blue is neutral, green and yellow is earth. Brown goes to L, blue goes to N, green and yellow goes to E, and it stays that way at both ends. Get the colors to the right letters, and the lead is safe. Cross live and earth, and you make the whole cable dangerous. Quick note before the terminals. Everything I draw here is in a free browser editor. No install, no sign up. It is at CircuitDiagramMaker.app, and the link is in the description. Open it and draw along. Start with the cable itself because the colors are the whole job. Strip back the outer sheath and you find 3 cores. Brown, the live. Blue, the neutral. Green and yellow, the earth. Now the trick that catches people out. When you cut the 3 cores to length, leave the earth a little longer than live and neutral. Here's why. If the cable ever gets yanked hard and the grip lets go, live and neutral pull free first, and the earth is the very last wire to come out. The safety conductor stays connected longest. Always. So, brown to L, blue to N, green and yellow to E, and earth cut that bit longer at both ends. Now the plug end, terminal by terminal. Open the plug, and you see 3 terminals, each marked. L for live on one side, N for neutral on the other, and E, or the earth symbol, in the center or the top. Brown into L. Tighten it down onto the copper, not onto the insulation. Blue into N, the same way. Green and yellow into E. On a UK, plug the live core runs to the fuse first, then the fuse feeds the L pin, so the fuse protects everything downstream. Every strand of copper goes inside the terminal. No stray whiskers poking out. No insulation trapped under the screw. Give each core a gentle tug. When you are done, it should not move. Now walk to the other end and do the socket, the trailing socket the appliance plugs into. Same 3 conductors, same 3 letters. Brown to L, blue to N, green and yellow to E. The colors run straight through the cable. So live at the plug is live at the socket, and earth at the plug is earth at the socket. This is the part to double check. If you swap live and neutral between the 2 ends, the socket still works, but its live pin is now sitting on the neutral, and anything you plug in is wired backwards. Keep brown on L and blue on N at both ends every time. Here is the single most skipped step, the cord grip. At each end there is a clamp, the strain relief, that bites down on the cable. It must clamp the outer sheath, the tough gray or black jacket. Never the 3 inner cores. Why it matters. When someone trips over the lead or drags a tool by its cable, all that force has to land on the sheath, held by the grip, not on your terminal screws. Clamp only the thin cores, and the first hard pull rips them straight off the terminals. So, sheath into the grip, tighten it until the cable will not slide, and only then do the pull test. That grip, plus the longer earth, is what keeps a yanked lead safe. 2 numbers decide the cable itself, current and length. The more amps the tool draws, the thicker the cable has to be. And the longer the run, the more voltage you lose along the way. So a long lead for a big tool needs a fatter conductor, not a thin one on a drum. Undersize it and the cable heats up. In the plug, fit the right fuse for the load. A small fuse for a small appliance. The bigger one only for a high-power tool. And the earth is not optional. On any metal-bodied tool, that green and yellow core is what trips the breaker if live ever touches the case, instead of touching you. Test it for continuity end to end, and never, ever wire up a core that is cut, cracked, or crushed. Here is a real extension cord wiring diagram, open straight in the editor. Everything we covered is on one sheet. The 3-pin plug on the left, the trailing socket on the right, live in brown, neutral in blue, earth in green and yellow, running the full length between them. Follow any core, plug to socket. That is what a clean drawing gives you. Now, let us lay one out from scratch. Blank canvas. I search the symbol library and tap parts onto the grid. A block for the plug end, a run of cable, a trailing socket, the appliance it feeds, and a ground for the earth. These come from the free do-it-yourself pack the guest editor gives you. Then the wires. Press W, click one pin, click the next, and the wire snaps in with square corners. Move apart, and every wire follows. And here is something a plain drawing tool cannot do. Simulate it. There is a Real circuit engine inside the page. Hit Simulate and run it, and live voltages land right on the wires. If live and earth were crossed, or a connection were open, the numbers would tell you before a single core got crimped. That is a check no paper diagram can give you. When the drawing is done, one click opens the export menu. PNG